Okay, hello everyone and welcome back to another one of these sessions. Hello Evie, how are you? So, I'm feeling a lot better, thank you. Yeah, completely fine. I'm barely even coughing now, which is quite nice. So, as requested, I've selected from the last couple of years only, so until about 2019, perfect, good to hear. I've selected a bunch of what I think are the hardest questions from the last couple of years. But I want to preface something quickly. The last couple of years, so 21, 20 and 19, the exams were changed to be made easier. Okay, and I'm using air quotes there because of COVID, right? So you may have heard that 2019 they used predicted grades, 2020 they kind of slashed a bunch of topics, same with 2021. So these questions, some of them are pretty hard, but if these are still not hard enough for you, we can go further back. So we can go back to like 2015, you know, like 2018, 17, 16 and 15. And that's what I'm planning on doing over the next few weeks. So just basically picking the hardest possible questions, unless there's demand for another topic. So I think that might be the best thing to do. So again, I've selected what I think are the hardest questions. Let me know if they're easy or hard, and we can just get started. But I will just keep going further and further back. In terms of exam boards, they're from a mix of exam boards because like I showed you in that short video a week or so ago, the exam boards all ask the same thing. They have the exact same specs. So they're basically all the same. Okay, so with that out of the way, let's just get started with some somewhat difficult maths. So the first question is, this was a question that, again, so the way I've picked these, by the way, is I also went through some of the examiners' reports, so the ones that most people struggled with. Because I thought that would be quite a smart thing to do. So there are 4 types of cards in a game. Each one has a black circle, white circle, or a black triangle, or a white triangle. And they give you some ratios. So the number of cards of the black shape to white shape is 3 to 5, and circle to triangle is 2 to 7. Now, as you may see, that there's an overlap here, right? Like the circles, it's white circle and black circle to black triangle, white triangle, and then obviously you have circles, and then triangles and triangles, right? And we have to find out the total number of cards with a black shape as a fraction of the total number of cards with a triangle. So we're looking for basically black over triangle. And there's actually quite a few different ways to approach this. My personal idea is I want to change the black shape into an actual fraction, right? So if I have black shapes, what's the fraction I can get? Well, it's going to be 3/8 of the total number of cards. Remember, both of these ratios are out of the total number of cards, so they have that in common, which is important. Then we do the same with the triangles, because again, that's what we're interested in. Now with the triangles, they take up 7/9 of the total number of cards. Okay? Now, because there's an overlap, like I said earlier, so both of these ratios are out of the total, right? Because we have black shapes, we have different shapes. That makes sense, yeah. We have different colours with different shapes and they overlap. What we can do is find the lowest common multiple of 8 and 9 in order to work out the total number of cards that we have. Okay, and the lowest common multiple, there's a bunch of different ways. Hey Lila, how are you? There's a bunch of different ways to work that out. In this case, I just know it's 72 because 8 times 9 is 72 and that is the lowest common multiple. So what we can do is times this fraction. Well, we don't even really need to do that. We can just work out that the lowest common multiple, 8 and 9, is 72. So again, there are a few different ways that you can do it. You can times the fractions together and do all kinds of wacky stuff. But so far, is it okay that 72 is the total number of cards? And again, the reason for that is because both of these ratios are out of the total number of cards in the bag, or in the deck, I guess you would say, yeah? Perfect. So the lowest common multiple between both of them will be the total number of cards, because they're both simplified versions of the fractions. Okay, great. It seems like you guys are fine with this. Okay, cool. So now we're pretty much done, right? We know there are 72 cards in total. We want the number of black cards, so 3/8 of 72, right? So the number of black cards is just 3/8 of 72. Oh, by the way, just so you know, I wrote non-calculator on top of the questions that were in non-calculator papers. That might be quite obvious, but just so you guys are aware. So 3/8 of 72, well, an eighth of 72, that's just 72 divided by 8, which is 9. 9 times 3 would be 27. Yeah? And then we have the triangle cards. Oops. Is 7/9 of 72, so 7/9 times 72. What does with a black shape mean? It's not a typo, so essentially, can you see with these cards, you have two different shapes, circles and triangles, but you also have two colours. So you have black circles and black triangles and white circles and white triangles. So what they're trying to say is express the total number of cards that are black, right? So all of the black circles and all of the black triangles as a fraction of all of the triangles. Does that make a bit more sense? So yeah, a ninth of 72 is 8, yeah, and times that by 7, so 21 is going to be 56. God, it's a bit worrying that it took me a second to work that out, but yeah. Perfect, okay, I'm glad it makes sense. So now, as a fraction, it's just going to be, so to make the examiner's life, so black 27 over 56. Or any equivalent, so you don't need to actually simplify it, but if you simplified it, then well done. Yeah, that's it. So there are a few other ways of doing it, but a lot of the... So I think the main problem with this is that a lot of students don't understand ratios at a very fundamental level. And as a result, getting to this step here is quite tricky. On a brighter note, if you just remember this, then you don't actually need to understand why. But in my opinion, understanding is slightly easier. So again, you both said it makes sense, so I'm assuming that was not too tricky of a question. But again, in the last few years, the questions weren't too bad because of COVID. But we can go back further, and some of those questions can get really tricky, which would be fun. So another one, I think it looks worse than what it is. So another non-calculator, we have two shaded shapes, you have A and B. B is a circle, A is a part of a sector. And we just need to find the value of x, right? But it tells me, and this is the key bit, is the area of shape A is equal to the area of shape B. So what I like to do, and again, if you're ever unsure, start working stuff out, right? So find out the value of x, you might think, okay, I have no idea what I'm doing. Right, which is reasonable, right? It's a tricky question. But what you can do is, yeah, this one's pretty good. What you can do is just start working stuff out and you get marks, okay? So this is a 5-mark question. 5-mark question. So start working stuff out. So let's work out something quite easy, the area of B. Right, I like to start with the easier stuff, so I build up a bit of a momentum. So B is a circle. And to work out the area of a circle, you do pi times radius squared. Now the radius, and this is actually where some students messed up, they subbed in this as the radius. But that is actually the diameter, so you need to half it. Okay? So pi 1 minus x squared. That's it. Okay? That gives you a mark. Straight away. I haven't really done anything, haven't got any closer to the answer, but I get a mark, okay? Now again, if you're wondering why students made that mistake, it seems a bit obvious. When we're doing this lesson, we're relatively relaxed, right? Or at least I hope you are. So when you're in an exam, high pressure, easy to make mistakes. Okay, now let's work out the area of shape B. This is a bit trickier, right? A bit. Sorry, of shape A, I mean. So it tells me that shape A is this big sector minus this small sector. So, a few things you need to remember. How do I work out the area of a sector? Well, it's important to remember that a sector, right, is just a fraction of a circle. That's literally all it is, right? It's a pizza slice. Okay? So, okay, how do I work out the area of a circle? Well, it's just pi r squared. And then all you need to do is times it by the fraction that you have. Make sense? So a sector is like a pizza slice, it's a fraction of a circle. If you know what fraction of a circle it is, all you need to do is take that fraction of the area of the whole circle, right? Cool. Now the question is, how do you do that? Well, something that they give you 99% of the time, good, is the angle, right? Now, angles in a circle are meant to be out of 360, but we have 45 degrees. So the area of this is going to be, so if we work out the area of the big sector first, right, it's going to be 45 out of 360 times pi r squared. And the radius in this case would be 2x plus 3x minus 1, so that would be 5x minus 1 squared. Yeah? Now that's not this area of A, that's the area of the whole pizza slice. Now I need to subtract the area of this smaller pizza slice. So subtract, again it's still 45 over 360, but the radius this time has changed. It's now 3x minus 1 squared. I don't know about you, but that's hideous, right? So what we can do is we can tidy it up a bit. So first of all, 45 over 360, can you see that that's just an eighth, right? 45, 90, 135, 180, and then double it so it'd be an eighth. So what I can do is I can make both of these 1 over 8, which makes it look slightly less hideous, and actually factorize out an eighth pi. This step might be a bit confusing, and that's completely fine. If it is, we don't actually need to do it. But I can pull out an eighth pi, and then just leave inside the brackets 5x minus 1 squared minus 3x minus 1 squared. I'm going to stop there. Is that bit okay, or do you want me to just leave it? Because I don't mind just ignoring it and not using that. You don't need to. Is that okay? It's fine. Lila, how about you? If not, completely fine to go back. Okay, cool. So far, we've earned 2 marks, and we haven't really gotten any closer to working out x. But you can probably see what you have to do now. The key information is this thing here. The area of shape A is equal to B. So now we can actually equate these two things. And then this whole monstrosity here. Minus. Equals. Okay. This is just a quadratic, which you all know how to do, right? Cancel out the pi, expand the brackets, simplify, solve, done. Okay? So, in my opinion, so again, this is what the examiner report found as well, is getting to this step was the hard bit. From here, if students made it to here, they got the answer right, because it's just a quadratic. And we all know how to do quadratics, right? We're all fine with that. So let's start doing it. Something you might consider doing is timesing both sides by 8. The reason why you might want to do that is to get rid of the fraction here. So if I times by 8, is that okay? And that means we can actually get rid of those first set of brackets, which looks a bit nicer. Yeah, okay. Okay, now let's get into the hard bit. Actually, I just realised we don't even need these brackets either because there's nothing outside them anymore. So let's start expanding. So 5x times 5x is 25x squared. And then you'd have minus 5x would be minus 10x and plus 1. If you're unsure about how I've expanded this, just let me know. Now, here's another bit which I can foresee people making mistakes, right? It's minus this whole bracket, so make sure you leave a bracket. So 9x squared, and then minus 6x plus 1. Because keep in mind, this minus affects everything inside the bracket, not just the first term. So some people write minus 9x squared and then they continue with minus 6x plus 1. That's not right. Okay? It's actually minus 9x squared plus 6x minus 1. Yeah? Bit tricky. Now I'm going to again do this in kind of one step. 25x squared minus 9x squared would give me 16x squared. Minus 10x plus 6x, because again it's add, just like Lila's saying now, would be minus 4x. And then we have plus 1 minus 1 would be 0. So it just equals 1 minus x squared. Is that okay so far? So if you look from the... Okay, I've made a mistake. The squared is meant to be on the outside of the bracket. You're right. I thought that was weird when I said it. I thought it was weird when I said it originally. I was like, oh yeah, it's not squared. As you can see, really easy to make mistakes. So yeah, 100% right. So just in case you guys didn't spot it, the whole bracket was squared up here, but then for some reason when I wrote it down here, I only squared the x. I don't even have an excuse. That was really stupid of me. So yeah, x squared. Thank God you saw that, by the way, because otherwise we would get a completely wrong answer. Okay, and that would be minus 2x and then plus 1. Okay. Now all we need to do is shove this all over to one side and we're done. Have I made any other mistakes just before I... I think I'm good, right? Okay, I think I'm good. Well played. Thank you, Evie. I appreciate it. So if we move everything over to the left-hand side, we have 15x squared, because we have 16x squared minus x squared. Minus 4x plus 2x, so we'd have minus 2x. And then minus 1 equals 0. And here's where things get a bit funky. Factorising this is impossible. Or extremely difficult, so it's better just to use the quadratic formula, and that'll be it. So x is equal to minus b plus minus the square root of b squared minus... And you don't really even need to simplify it, which I think is quite interesting. It's not the difference of two squares. The difference of two squares would be something like... is it easy to factorise that, Evie? It's not completing the square. Oh, you can use completing the square. You can use completing the square, you can use the quadratic formula, you can use factorising. Whatever you want to do. All completely fine. Oh yeah, of course. Oh man. I'm a bit rusty today. Wait, 15x minus 1 and what? 15x plus 1? And then, okay. Yeah. You could do that, yeah. So times to minus 15, add to minus 2. Yeah. Yeah, you're 100% right. My bad. Again. So we're looking for two numbers that times that, so it'd just be 15x squared. I know I do it a slightly longer way, but that's just because I find it easier to teach it that way. Minus 5x, and then plus 3x minus 1. Yeah, you can definitely do that. So we would factorise out 5x, and we get 3x minus 1, and then all you need to do is 2 plus 1. But any way you want to do it is completely fine. So you have 5x plus 1. I know, right? It's pretty good. So, yeah, well done, Evie. Well spotted, you can do it. So you can do it by quadratic formula, completing the square, or factorisation. Very well spotted. So we either have x is equal to minus 1/5, or x is equal to 1/3. But if we use our logic, it says find the value, singular. 9 times out of 10, you get rid of the negative one, right? if you want to know the reason why, let's have a think. What is x? Well, x is our diameter and it's our radius. It can't be negative. It's a length, right? So it has to be positive. So it would be x is a third in this case. And that's 5 marks. I think that was a harder question than the first one, but I think it was still doable. Again, if you still find this easy, next week I can pull out questions from the past like 10 years. And oh, this one's easier. Okay, fair enough. Yeah. Right. Next question, again from a non-calculator paper. Vectors, everyone's favourite. All you need to do is prove that PQ is parallel to FE, right? So this imaginary line that we have going across here. Okay. Now what I like to do first things first is, again, I'm trying to go through the exam technique so you guys kind of see where I'm coming from. I like to label up the thing. Yes. Okay, so the first thing I do, good, well done, well done. First thing I'd do is I'd label up my vectors, right? So it tells me that f all the way to d is A and f all the way to E is B. Now, what Evie's saying is probably the best way to start this as well. So the first thing I do is I label my diagram. I don't even think about the question. I just label, okay? The next thing is like, okay, prove that PQ is parallel to FE, okay? Now, for two vectors to be parallel, they need to be a scale or scalar multiple, of each other. Now, whenever I normally mention that for the first time, people can be a bit confused. So let's say the vector PQ is A, yeah? Then if these things are parallel, FE is just going to be some number times A. So normally they use the letter lambda, right? So it could be 2A, 3A, negative a half A, whatever, right? However, if there is some other vector B, we know that they're not parallel because you can't have a scale multiple of each other, okay? I hope that makes sense. Evie, I know that you're okay with it because you told me. But Lila, are you okay with that? Does that make sense? I think the delay on this is pretty long as well. Okay. Cool. So in this case, we know that FE is B, right? So what we're looking for is that PQ should be some number times B, right? So all we need to do is work out what PQ is. Well, let's have a think, right? So how can I go from P to Q? Couple different ways. We can go from P to F. Then we can go F to E. And then we can go E to Q, right? By the way, there is another way to do this, obviously. You can also go P to D and then D to Q. Right? And you will get the same answer. It doesn't matter. Which way do you guys want to do? First way or second way? The second way looks shorter, so we can do that. Let's just do it, actually. So, key thing here, yeah, second, cool. Key thing here is that P is the midpoint of F to D. So to go from P to D, that is going to be a half of A, right? The reason why it's positive is because we're going in the same direction as that. Now, I don't actually know how to go from D to Q, right? So, okay, well, Q is also the midpoint, so it's going to be a half of whatever D to E is. But I also don't know what D to E is. So let's try and figure out how to figure out D to E. Okay? So, if we take a break from that, the key thing with working out vectors, right, and this is just a rule you have to remember, is you have to go through vectors you already know. So I can't go straight from D to E. So instead I have to go from D to F and then F to E. Minus A plus B. Perfect, Lila. And Evie, are you okay with that? If that it's minus A plus B? You guys are really on it. Well done. So now all I need to do is sub this all into my equation, and I'm done. Your online lesson tool. Ah, perfect. So half a. I'm glad to hear that it's helped you. After all, that's the whole point of being here, right? Plus a half times minus a plus b. Now hopefully you can see that this half a is going to cancel with this minus a half a, and we're just going to be left with a half b, which, if we look at fe, it's good. They have the same letter in common. So P to Q is just a half of F to E. So they must be parallel. Not bad. Let me go through it. I did skip a step. That was a bit not good of me. So let's expand the brackets, yeah? We have a half a. A half times minus a is going to be minus a half a plus a half b. So we have a half a minus a half a, so they cancel out. Okay. Well done for asking questions. It's really, really good. So just so I can check in with you guys, how are these questions? Are they easy, medium, or hard, would you say? Just so I know for next time. Easy. Okay. Lida, what about you? Medium? Okay, so we can go a bit harder then. Okay. Next week. Next week I'm going to have to go a bit further back then. Good. I did think you'd find these relatively okay, to be honest. Okay. So. Okay. These questions come up a lot. And actually, I'm not going to lie to you, not a lot. These questions come up occasionally, and they catch people out. But if you remember how to do it once, capture, recapture exactly. If you remember how to do it once, you will never get a question wrong ever in your entire life. I promise you. So all you need to do is know how to do it once, right? So what we're going to do... By the way, this is actually how scientists do this in real life, right? Like if you ever wondered how they work out how many birds are in the UK or how many bees, they obviously don't pick them one by one, right? They do exactly this, right? Oh my goodness, alright. I actually do it the other way, Evie. Slightly different way. 90 over x equals 20 over 120 is how I do it. Good, okay. So yeah, this is how they do this in real life, okay? So, on Monday, they catch 90 bees, right? So we have 90 bees. Let's write down 90 bees, yeah? And she puts a mark on each bee and returns it to their hive. How do I know that? So basically my degree's in physics, and sampling is actually quite a big part of physics. So they know all sorts of weird things. But what they do is they do this exact method. They catch a certain number of bees, right? They then tag them, let them go, and then they come back later and catch them again and sees how many of them have been marked. And from there you can work out how many are in a population. It is an estimate though, as we can see in part B. There is an estimate here. Okay, so you have 90, and then what happens later is she catches 120 bees and only 20 of them have been marked, right? So in total we have 20 out of 120 have been marked. Now the assumption here is that the proportion is the same. So when she caught 90 of the bees, she tagged 90 out of n bees, where n is the total number. Right? So when she caught 90 of them, she caught 90 out of a total number of bees. Yeah? Then when she lets them go, she comes back the next day and she catches 120 of them, but only 20 have been marked. The idea here is that the proportion stays the same, assuming none of the marks have been rubbed off. And that's the mathematical trick that I was about to call them bee people. Man, that was stupid. Scientists use in order to estimate the numbers of animals in a population. Because with things like insects, you can't catch all of them, right? Like with ants, there are trillions of ants. You're not going to count them, are you? You do a similar thing. You tag them. Okay? Does that logic make sense? If you want, you can memorize this, and it will always be the same. I should also say that there are different ways of working this out, but this is my favourite method, okay? And personally, I find it the easy one. And then all you're doing is rearranging for n, right? Easy algebra times both sides by n, right? So we have 90 equals 20 over 120n, and then cross multiply it. So you will have, actually no, let's do it step by step. Let's not be too hasty. 90 times 120 equals 20n. So now n is equal to 90 times 120 over 20. It does say estimate, but unfortunately you can't actually estimate it. But what I will say is you can cancel out the zeros. So now you have 9 times 12 over 2, which is a bit easier, right? 10 times 12 is 120, so minus 12 again is 108. So we just have 108 over 2, which is 54. So 540, sorry. Because I've taken out... Wait, just so I can show you clearly. You can cancel one of the zeros, right? But then I've ignored the 0 so I can work it out. That's probably confused you, hasn't it? Okay, so I'm trying to work out 90 times 12. I just did 9 times 12, and then you can add a 0 on afterwards. I skipped a step there. My mind went a bit blank. I apologise. But you can only cancel out one of the zeros because they're times by each other, right? So that gave me, instead of 90 times 120, it's 90 times 12 over 2. 90 times 12 is a bit hard to do, so I did 9 times 12 and just added a 0. If you want, you could literally just do column method, right? 120, 90, 0, 0, 0, add another 0. 9 times 0 is 0, 9 times 2 is 18. 9 times 1 is 9, add the 1. And then you're just halving that once you've added them together. So you're more than welcome to do that if you want. You both say that you see, so I'm assuming that's okay. I did kind of speed that up a bit, which I shouldn't have. Okay. So, now, this assumption is always the same. So I've seen them do it with things like tadpoles, frogs, birds, all sorts. But it doesn't matter, right? It's all the same. Shirley assumes that none of the marks have been rubbed off between Monday and Tuesday. If the assumption is wrong, explain what effect this would have on your answer to part A, right? So, if some of the marks have been rubbed off, right, then this proportion isn't actually the same, right? So what I mean by that is this number here would actually be bigger if some have rubbed off, right? Because instead of being 20, it might have been 21 or 22, but 2 of them have rubbed off. Does that make sense? Now, if I look at my answer, the 20 appears on the bottom of my fraction. So if that number should be bigger, the actual number of b's should be smaller, because I'm dividing by a number that's too small. Right, you both say yes. Perfect. Okay? So what the effect this would have? Well, it's an overestimate. So again, this is an extremely common question to get wrong in the 2019 Edexcel paper. I know it's Edexcel because, by the way, a little trick. It's Edexcel because these use curved brackets, whereas AQA use staple brackets, the square ones. Just in case you're wondering how I know. Because the actual style of question is basically the same, it's very hard to tell. It's just the way they write their marks that's different. Okay, you all okay with that? I mean, you've said yes, so I'm assuming so. Okay. And as you can see, staple brackets. So it's an AQA question. This was a pretty tricky. You've done it, yeah. It's an AQA question, so I assume you've done it. You know what? Next week, right? I'm actually gonna go back like really far, right, to like 2016, 2015. It's still current spec, don't worry. But I'm gonna find some hard questions for you guys, because I think you guys have done a lot of revision already, or you're very on it. So these questions aren't too bad. Can I ask, is this still useful? Even though they're questions you might think aren't too bad? Or do I need to make it harder for next week? Otherwise it's not useful. Lila, if you've done 0 revision, damn. It's a nice recap. Okay. Okay, next week, I promise you, I'm going to find some hard questions. They're questions that are going to make me sweat. You want mega hard. Okay. You know what? Fine. I'm going to write this again to myself. So mega hard, go pre-2018. I'm talking like 2015, 2012, that kind of stuff. Because some of those questions were hard. And I don't know if I can find the question again. I have a question on my phone which was extremely hard. Alright, I'll know what that means. That question here is like, yeah, it's called a grade 9 plus, right? So what that means is it's grade 9, but it's technically above a grade 9, right? That question, by the way, it took me quite some time. It is a circle one, but I'm pretty sure you have to draw the triangle yourself. Have you done it? Did you see it on Reddit? Because that's what I found it too. Not quite. It basically. Oh yes, you're right. Yes. Have you done it? You've just done it before. Are you kidding me? Fine. You might want to just give me a list of questions you haven't done. That might make my life a bit easier. But okay. Non-calculator paper. Vertices of a hexagon lie on a circle. Blah blah blah. Honestly, that's not too useful. Work out the shaded area. Give your answer in the form. So this looks ugly. Not too bad though. So, this shaded area, can you see that it's a pizza slice? Whoops. Little pizza slice. Minus this triangle. Can you see that? So, it's a sector minus a triangle. So, let's start with the sector. So, because we've already mentioned this before, area of a sector is just the fraction of an area of a circle, right? So, and that fraction just comes from whatever angle we have. So in this case we have 60 over 360. And then again it's pi. The radius in this case is 5 squared. Now the area of the triangle is a bit tricky, a little bit, right? Because it's an equilateral triangle. So I saw a few different ways that people did this. Someone like divided the triangle in half and used Pythagoras to work out the height and then did half base times height times 2. But just like Evie has just said, the quicker way is a half AB sine C. However, there is a problem, right? It's a non-calculator paper and there's a sine 60. This is where students made mistakes and things like that. So, just to kind of express it, you could split this triangle in half and work out the area using 2 right-angled triangles. So using half base times height times by 2. That's valid. Okay? But to do that, you'd need to work out this side. And the problem with that is this length is 2.5. So you're using Pythagoras with decimals, right? Which means you're going to have ugly fractions. But you can still do it. It's still 100% correct. But in this case, we need to know what sine 60 is. Hopefully you guys remember. 60 over 360, can you see that that's just a sixth? 5 squared is 25, so a sixth of 25 pi, minus 5 times 5 is 25, so 25 over 2, so let's leave it as a half times 25. And sine 60 is root 3 over 2. Well done, Lila. Apparently you do know. So yeah, that's correct. Okay, that's all good. So, that's completely correct, yeah. So that's going to be, I want to make this a fraction. That's the only time you're ever going to hear me say I want to make something a fraction, by the way. 25, oh god, what am I trying to write? Alright. 25 pi over 6. Now this as a fraction, we have 25 root 3. That is 25, yeah, okay. My handwriting's so bad I couldn't read it for a second. And a half over 2 over 4 like that. I'm going to leave you 1 second just to make sure that's okay. My handwriting was absolutely awful here, jeez. Alright. So a half times over 2 gives me the 4. And then I left the 25 next to the root 3. The reason for that is, look at the answer. It's something times pi, so 25 pi, minus b root c, so we need a number times the square root. Okay? So that is a bit tricky. Show the 4. Well done, Evie. As in how I got to it? Yeah, sure. So let's do it in a couple of steps instead. So first of all, I'm going to just leave the half outside, times 25 root 3 over 2. Kinda. Not quite. Because we're timesing, right? Now when you times fractions, you times the top and you times the bottom. That's where the 4 comes from. Okay? So we have 25 pi over 6 minus 1 times 25 root 3, so that's just 25 root 3. That's fine. 4. And Evie's already done it. Show off. No, I'm kidding. We need to now combine the fractions, right? And to combine the fractions, we need to make the denominators the same. The lowest common multiple of 6 and 4, hopefully you can see, is 12. If you don't know that, like if you ever get to a stage where you need to find the lowest common multiple, you can't work it out with the fraction, you don't need the lowest common multiple. All that matters is that afterwards you can cancel down. Like if I did 6 times 4 and I got 24, my bottom becomes 24, but I'll be able to cancel out the top to make it 12 again, right? That's how maths works. It's super handy in that case. So times by 2, times by 3, and then we get 50 pi over 12 minus 75 root 3 over 12, which, as Evie has just said, is going to give me 50 pi minus 75 root 3 over 12. Okay, so A is 50, B is 75, C is 3. That all works. It's completely legit. All good? Yeah. So I just want to point out that with these hard questions, and I'm going to put them in air quotes for a second, if you just start working stuff out, generally a solution presents itself, right? So, like for example, like work out the area. It looks complicated. There's a hexagon inside a circle. Like what the hell? That's crazy. But just zoom in for a second, right? You have a triangle and you have a sector, and then move on from there. Okay. All right. This was a funky. I was about to say A-level question. I meant AQA question. But it wasn't too bad. It's not too bad at all. So, okay. Anyways, the flight of a plane was in 2 stages, and it shows you some information. They give you distances, they give you speed, and therefore they give you the time it takes. And it says in total the flight lasted 2 hours. Now, this question bothered me. It's 5 marks, by the way, pretty big. It bothered me because this information is actually completely useless. You don't need it, right? All you need to know is that the flight lasted 2 hours, and this is how long it took in 2 stages. So what we know, again, just think about what you know. You have 731 over x plus 287 over x minus 24 equals 2. That's it. So yeah, kind of a frustrating question, but I guess it is what it is. And there are a few ways to do this. You can combine the fractions, but that's quite tricky. Honestly, the hardest part of this is the fact that the numbers are quite big. But what I would do is I would times through by x first to get rid of the first fraction. So that gives me 731 plus 287x over x minus 24 equals 2. And then I want to times by x minus 24 to get rid of that fraction. And this is where it gets a bit ugly, because we're going to have to do some annoying calculations, to say the least. So 731 Man, my algebra has been really sloppy today. You're right. Oh, thank God you're here, Evie, honestly. I hope you guys know by now I'm not normally like this, yeah? I don't know what it is. I think I didn't get enough sleep. I don't know, the moon's in the wrong place. Something's up with me. Oh, God. Equals 2x. Okay. Yeah, this time I remembered. Good. Damn. Yeah, something's up. I'm trying to think. I'm trying to think. Story of my life. Yeah, this is going to be ugly. Is there an easy way? Hold on, let me see if there's a shortcut. Move over that. Nope, I can't spot one. Basically, we're going to get a quadratic. Now, of course, the problem is if we expand this bracket, right, 731x, we now need to times 731 by 24. Not really any easy way to do that. We just have to do it tediously. Unless you guys can spot something. I know you can times by 10, double it, and then you left over with something, but I don't think that would help really. 4 times 1 is 4, 4 times 3 is 12, 4 times 7 is 28, plus 1 is 29. And then just cross that out. Then we add the 0, then we have 2, 6, and then 14. Add them all up. 4, 14. Yeah. Good lord, why is it so big? Alright. 5, 4, 4 plus. And then we have 2x squared minus 48x. Okay. And now we're going to have to do a bit of praying, unfortunately. In the sense that we're going to have to hope that things cancel down to make our lives a bit easier. On the bright side, again, there's no way we're going to factorise this, I don't think. But, you know, let's see. What can we combine? So 731 plus 287. I think I've reached my limit of mental maths today. 8. Oh, okay, that explains why. Yeah, 1018 minus all of this Good lord. Okay, wait. Yeah, this is pretty bad. Yeah, okay, we're doing it right, it's just a really awkward question, okay? It is a 5 marker, so we have to expect that there's going to be some level of pain in this. I know, that's what I was hoping for. On it, they're all even numbers, so we can half everything right now, right? the thing is, even halving this, it's like, it's still huge. It's still massive. Okay, so I want to move everything over to the right-hand side. So we have 2x squared. Then we have negative 48 minus 1018. So that's the same as just doing 48 plus 1018, then just sticking a negative. So that would be 1066 is what I meant to say. Yep. So that's negative 1066. And minus. Damn! Alright. Completing the square won't help. Lord knows that. Again, we can half everything, right? So x squared minus 533. I don't know why that was difficult for me to work out. That one's a bit harder. So 17,500. So it'd be 8,700. You know what? Screw it. I can't trust my mental maths today. Bad things are happening, so I'm just gonna take the L. 8 remainder 1. 7 remainder 1. That'd be 7. That'd be 2. Yeah. Okay. Oops, forgot the X. Okay. So, there's no real easy way around this. However, one blessing, by the way, is if you get numbers that are this ridiculous, you can leave your answer like this. So all you need to do is sub in to the quadratic formula, and even if you don't simplify it, you get the marks. Okay? So that's all I'm going to do. Unless you guys are really mean and you want me to work this out, which I really hope you don't want me to work it out. I can, it's just excessively long. Right? Yeah. Okay, so... Wait, Evie, are you saying you want me to work it out? I really hope not. Okay. Let's work it out. Alright. Just trying to limber up a bit. Let's go. That's quite easy, 533. Plus minus. Right. This is where the problems start. 533 squared. You know, I wonder if I can just use a calculator so that you can't see. No, I'm kidding. I'm not going to do that. Okay. I do want to point out, though, that leaving it in terms of the quadratic formula is fine. But 3 times 3 is 9. Let's suck it up, and that's 15. This is going to give me the exact same result, so I'm just going to copy it down. 5, 1. 5 times 3 is 15, so carry the 1. 5 times 15 is going to give me 16. 5 times 5 is 25. Add the 1, sorry, is 26. Mother of God. That's 18. 10. That's 20. 66 is 12. Plus the 2 is 14. Hey, you asked for this. You asked for this. 284,089. You really want me to do this, yeah? 284,000. You know it's good when you have a quadratic formula that has a comma in it, right? Alright. Oh, you know, I feel like I could do this in my head. Like, double it and double it again. But I know I'm going to make a mistake. I'm not in the right state of mind for that. So... 2 times 2 is 4. 2 times 7 is 14. Add the 1. That would make that 15. 2 times 8 is 16. Add the 1 is 17. Good lord. And that will make it a plus as well. I'd like to point out, Lila, this is optional suffering I'm doing right now. You can leave it as a quadratic formula. So, alright, adding those two, even just adding those two numbers is quite difficult, isn't it? Oh, I did not space that out very well. 9 plus 4 is 13. That's also 13, that's fun. That's 6, that's 11, that's 10. Oh, okay. Okay, no, I left the thing there. Now, you can leave it like... You definitely can leave it like this. Right? I'm sure you've seen answers like that before. So that would be my answer. Wait, where did the 35088 come from? Why did you not put 35088? Oh, 25088. Oh. You're right. I timesed it by 2. What am I doing? You're 100% correct. Man, today is not my day. You know that. Today I'm... Yeah, no, you're 100% right. I times by 2 instead of 4. I know why. I know why. It's because I said I can double it and double it again. So I just times by 2. You feel bad for me. Yeah, you know what? I feel bad for you guys. I'm not operating at 100% today at all. God, how many mistakes is that? I've got a feeling I've made more mistakes in this last like 40 minutes than I have in like the last few weeks of lessons. Okay. If you want to have mercy, leaving it like this, obviously assuming that this number was actually correct, would be the right answer. It's the moon, yeah. I think it is. It's just in the wrong place. The gravity's, you know, is tripping me up. Can I leave it like that even though it's the wrong answer? Oh god, I'm so annoyed. Okay. Again, thank you for spotting all my mistakes, Evie. You're 100% correct. But yeah, you can work it out, but you can leave it like this, right? We only have a couple minutes left. I do have a couple of questions. Alright, I do have some announcements I want to make that I've wanted to make for the past few weeks, but like, we had some issues and stuff. Actually, I don't know if I made one of the announcements. I can answer a question you have, yeah, absolutely. Yeah, sure. Was that another? Okay, can I save these next 3 questions for next time? This question is actually pretty tricky, I'm not going to lie. This one I think some people would struggle with. Let's do it next week then, yeah? So from this onwards, do next week. If you want to start writing up your question, Evie, I'm just making a note to myself. Then super hard pre-COVID questions. So while Evie's typing up her question, or sending it, whatever. Is the radius they give for circle questions always a squared version? Okay, depends. So if they give you an equation for a circle, let's say x squared plus y squared equals 25, then this is always squared. 100% of the time. If they say the radius is 5, or they imply it, then it's not squared. That's the difference. I'm assuming that's your question? If I completely misunderstood your question, then I'm sorry, but I think that's... Yeah, okay. Cool. Okay, that was a lot easier than I thought it was. Yeah, no worries. So yeah, I just want to go over this one more time, just real quick. Basically, since COVID, the papers were made easier for a couple of years, right? So they skipped stuff out. You know, if I'm being completely honest with you, I've never done the proof for the quadratic formula. I assume you do it in uni maths, but I did A-level maths, I never did it. I've studied A-level further maths for tutoring and stuff, never did it. In university physics, I never did it. But if he showed you the proof, that's kind of cool, I guess. Kinda. But yeah, so essentially for the past few years, the most recent exam papers are a bit easier. And I'm using air quotes because I know 2022 the papers were very hard, right? Again, they're changing that for the past year and obviously for next year. So what I would recommend with your revision is try and do, and this is what we're going to do together, by the way. So if you don't want to do it, okay, I worded that wrong. If you want to focus on the more recent past papers, you're more than welcome to. But in these lessons, I think for you guys, I want to focus on 2018 and before, because the questions were slightly harder, and I have a very strong feeling that they're going to make them hard for coming year. Right? Now this isn't something to be scared of, because your grade boundaries would be quite low, right? Because everyone would do worse, right? Which is fine, right? Like if everyone does really bad, grade boundaries are really low, you'll still get a good grade. Don't worry about it. But I think if we practice 2018 and before in these lessons, it will give us a good foundation for your exam in May, June time. That's my theory. In your own personal revision, feel free to keep doing 2019, 20 and 21. Completely fine, but I have a very, very strong suspicion, which is also why they made that threatening announcement of not giving you a formula sheet, even though they probably are giving you a formula sheet now. They want to step it up. They want to step up the difficulty. The main reason is that when people go to university, there's a certain level of maths that they expect you to know. Same with A-levels. So they want to make it slightly harder. Okay? How do you even do personal revision? Honestly, with the stage you're at, I'd recommend start doing past papers. But do it from Edexcel, Educas, AQA, do all of them. But it's mainly just finding questions and doing them. Yeah, good. If you're up for a challenge, yeah, I can show you some really challenging questions, which will really develop your math skills in general. Getting better at maths is obviously a good way to study. But yeah. Okay, announcements. A couple of things. Three main things. One, this is my last week at school, so I'm assuming it's your last week at school as well. So I'm still going to be doing lessons every Tuesday. Don't feel obligated to join. I know it's Christmas, you want a break, you deserve a break. I want you to know that. You probably won't hear it from many people. You deserve a break. GCSEs are very hard. So feel free to watch them afterwards, right? Like when you come back to school, feel free to watch them then. You don't have to join in live. Completely fine. Don't worry about it, okay? Feel free to watch them afterwards. I also upload edited versions after the fact as well, so you can just watch those if you want. No obligations. Don't worry about it. Two, this sounds a bit like an oxymoron now. I would appreciate it if you guys would kind of share around the videos. The reason for that is it helps me a lot if you could do that. And if you're honest, but first of all, only do it if you find it useful, right? If you don't think your friends will benefit, then don't worry about doing it. Which software do I use? Good question. So from this, I use Microsoft OneNote, and I use a graphics tablet, so that allows me to write on stuff. And I'm using OBS as streaming software. I also have like a HD webcam and a pretty decent mic. Okay, I'm just pause for a sec. So Lila, past papers make me so stressed out as I forget everything, like what a modal class is. Good, right? It's good that you're doing that now rather than later. You have like 6-7 months until your exam, right? It's good that you're forgetting stuff now rather than later. Practice, 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 okay? And it'll get easier. And you'll recognize how the questions look, right? Like when I see sketch the graph of and I see a quadratic, I'm already thinking, okay, I'm going to factorize, equate to 0, done. Like, it's just a gut reflex, right? You'll get better. So yeah, by the way, I hope understand physics. I hope that explains what I'm using. So yeah, OBS and also Microsoft OneNote with a graphics tablet. I'll join all your live lessons till maths exam. Yeah, I mean I figured I wouldn't expect you to join afterwards, but yeah, if you could share it around, that would help me out a lot. I also like it when there's like lots of people. You know, I like people. So, but only if you think it's useful. If you don't think that this would be useful for them, obviously don't recommend it to them, otherwise it'll be bad. Till you get your play button. One day. The last announcement, I actually forgot I did this, but earlier in the year, I actually made predicted exam papers for Edexcel and AQA, Higher and Foundation. I made like 3 paper 1s, 3 paper 2s, and 3 paper 3s. And the reason why I did this is I actually was going to sell them originally, but also because I tutor people and I wanted to help them out. They ran out of exam papers to do, so I gave them predicted exam papers, and apparently they were pretty good. Apparently. So what I was thinking of doing is, so you can see what they are, is I was thinking of doing a video or a live stream where I go through one of the papers, right? And if it looks like something you're interested in, then maybe we can do something afterwards, yeah. But they are predicted, right? So they're what I personally think the exam will look like. Because I'm pretty sure this year, no one actually knows, right? Because they haven't decided yet, because they're annoying. I'm pretty sure this year it will be a proper, full paper, okay? No topics missing, no nothing. So, that's what they're based on, right? They're based on the last few years of exam papers. Well, not 2021, 2020, 19, 18, 17. Took bloody ages to make. So I literally went through and... what do you think the last question? Can I confess something? I haven't actually looked at the paper recently, so I'm not sure. But essentially I have a spreadsheet. Something else that might be useful to you. I have a spreadsheet of all of the topics that came up for every single question for the past few years. So question 1 was it, what was it? Rationalize the denominator, algebra, whatever. Question 2 this, question 3 that, question 4 that. I'm thinking of letting that go. That's a good bet, Evie. That is a very good bet. So, yeah. It sounds like you guys are willing, it sounds like you guys are interested in the predicted papers, and also would you be interested in the spreadsheet of all of the different topics that came up in every single question? Yeah, okay. Okay, perfect. So one thing of doing then is just doing a video where I go through one of the papers I made, and then from there we can see what's up. You two are both AQA, so I'll do the AQA one. I also have them for Edexcel. Some of them, so I basically recorded answers and mark schemes for all of them as well, by the way. So I've literally gone through every question and I wrote out answers while talking over it, but I also have a mark scheme for it too. So it's pretty much a complete thing. So yeah. Okay, cool. I just wanted to get your guys' opinion on that. Other than that, next week we'll finish off the 3 questions I have left, which were pretty tricky, and then we'll just do super hard pre-COVID questions, and I think that'd be good. And then at some point I'll do the predicted papers too. Again, now that from Friday I'm going to be off. Should be a millionaire for all that work. That's the dream, Lila. That's the dream. One day. But yeah, I do appreciate your guys' support. You've been very lovely to teach and help out and like interact with. But yeah, since I'm finishing on Friday, I will have a lot more time to upload more stuff. Again, don't worry about watching it. You don't have to. But it will be there for January, okay? But I'll upload like a bunch of different stuff. I may even start doing GCSE Science as well, if I can. If I can. So yeah. Yeah, you're very welcome, both of you. Thank you, that's very nice to hear. I really appreciate that. Yeah, other than that, I'll let you guys get on with your evening, and I will see you in whatever the next one that you join is. That was English, sure. But yeah, I hope you guys, if I don't see you over the half term, Have a nice break. Exactly. Thank you, Evie. Enjoy your break. Relax for quite a bit, and then we can hit the books quite hard in January and get those 8s and 9s, right? Definitely. Yeah. I definitely should have stopped recording. Oops. Yeah. Thank you so much. See you guys later. Yes.